I'm Robert J. O'Neill, former Navy SEAL. As a Navy SEAL in combat, we were able to pretty much bring anything we wanted. I carried EOTech with me on over 400 combat missions because of its speed and precision. One of those missions was the night I killed Osama bin Laden. So I was invited to take a tour of the facility, and I'm taking you with me. Let's go. So here we are at the headquarters just west of Detroit, Michigan in Plymouth. Behind me is a 100,000 square foot facility where they make the EOTech holographic sight. 100% made in the USA, and we're going to go check it out. Even as you first step inside the building, you can tell that EOTech technology is far better than your standard red dot, from its number of patents and rich technological history dating back to the 1950s. EOTech's accepted worldwide by military and law enforcement and became the primary close quarters battle optic for US SOCOM. So unless you've been living in a cave, I'm sure you've seen the EOTech holographic weapon sight on video games like Call of Duty, movies like John Wick, American Sniper, and TV shows like The Unit. And it's always on top of the good guys' guns. Okay, now that we know the history, let's see how these things are made. Follow me. So all the HWS advantages start with the hologram. So let's get kitted up in our safety gear and go see how it happens. It all starts with EOTech's optics lab and an extremely powerful laser. Glass plates are inserted to capture the reticle image infinitely across the plate. Once captured, the plates are processed and exposed, similar to the photographic film process. Once the images are exposed, the plates then move to get tested, and cover plates are bonded to each side of the image plate. After curing and protective film is applied, the plate then moves to the water jet, where the individual images are cut out and cleaned. Once cleaned, the critical piece that drives this technology, the holographic image, is ready for assembly. Okay, so after we get out of that gear, we're going to put on some more gear, and we're going to see what they do after the laser process, how they make this. Now, assembly of the housing begins through a bonding phase. The housing is made of glass-filled altum, a material that performs extremely well in all conditions. First step is bonding the collimator mirror into the roof of the housing. The collimator is a critical part of the optical path that focuses the beam of light from the laser diode. Adhesives are applied and UV cured for a solid bond. Next, the holographic image and front window get installed. Adhesive is evenly dispersed for a tight seal. Once installed, the housing is tested to ensure proper alignment of the collimator mirror on the X and Y axis. The bonding is complete after proper cleaning and inspection. After bonding is complete, the housing moves to the flex body phase. The flex body is a critical component in the sight's optical path and redirects light from the laser diode. Windage and elevation shafts push on this flex body to adjust the position of the reticle. Here the gradient lens is installed and bonded. Next, windage and elevation shafts that will move the flex body are installed, as well as the battery compartment. The housing is now ready for the base to be installed. To do so, the primary mirror must first be carefully glued to the base. The base is then attached to the housing using an alignment fixture and then screwed down to the housing. The last part of the assembly process is the installation of the electronics that include the button assembly and laser module. A Z-axis spacer is installed that sets the sight's parallax to 200 meters. Windage and elevation are tested to ensure proper travel, and the module is torqued down. The holographic sight is now fully assembled, but isn't even close to finding its way into its box. Next, each EOTech sight takes a spin on the thumper that simulates 40 rounds of punishing recoil. Once complete, the sight's windage and elevation are tested once again for consistency. Then, each sight is pressurized and nitrogen purged to check for leaks. When passed, the sight is now ready for an exhausting inspection process and then moved to pack, where the sight is packaged, boxed, and ready to ship out. All right, so you've seen how the magic happens. This is the final process in packing. Get ready to ship it out to a retailer near you. To build a weapon sight that can endure the harsh conditions and abuse related to battle, you must test it in advance. Throughout the years, EOTech has invested heavily in test equipment to torture the products and understand their performance. First, the test lab includes a separate recoil simulator, just like the one on the production line, used to qualify existing products, new improvements, and new product designs. This thumper can push the limits of extreme recoil through G-forces exceeding 1,300 to 1,400 Gs. The test lab can analyze parallax performance and reticle focal distance, as well as perform a wide variety of tests consistent with the military's mil standard H10H environmental protocol. Then there's thermal drift. This is the impact that drastic temperature changes have on materials. When temperatures go from extremely cold to extremely hot, or vice versa, all materials will react differently. This means that the steel barrel on your rifle, brass casing of your ammunition, or optical components of your sight could be affected. EOTech owns and operates what might be the only thermal drift test facility in the entire shooting industry. An integrated oven-to-freezer system allows for immediate changes in temperature ranging from low temperatures like -40 degrees Celsius to high temperatures of 70 degrees Celsius. Test engineers are able to take sights immediately and measure the changes of the sight's performance in real time. This understanding ensures that the products that EOTech boxes up meets their specifications, but also provides testing of new designs or material changes in hopes to minimize these effects. This, along with the durability and reliability of the holographic sight, is why US SOCOM awarded EOTech another close quarters sight contract in 2018. So there you have it. This is not just an ordinary red dot. EOTech comes with science, technology, and a whole lot of engineering. Oh yeah, and it's 100% made in the USA. I'm Robert J. O'Neill. Thanks for coming with me.